the guy just left. Okay. Yeah. That's it.
I didn't hear him. I'm dumb.
Absence. Okay. Don't say that about yourself, even if you're joking. Before we're going to solve this first one, I want you to predict, where is JKL prime going to be, and will it be the same orientation? Example 1 is going to have us do this. Rotate 180 clockwise, counterclockwise about the origin, and then reflect it across the x-axis. We're no longer doing one thing, Elliot talking one, but we are doing two. Where is this going to be? You can predict it by just putting a star next to the quadrant that it's going to be in. And then, is it going to be in the same orientation? Meaning, will it be straight up, or will it be kind of flipped, or upside down, or flipped the other way? Turn and talk to your partner. Two questions you're answering. Where is it ending up? Same orientation. Go. Predicts. Yeah.
Literally watch this. My V was connected.
No, it's not that close.
270 is the same as 90 degrees. It's not 270. It's this one.
No,
It's the bottom right.
why?
Because you're flipping it 180. It's 180. Kylie.
Oh yeah. My bad.
Tanner.
My bad.
Which quadrant is it? Which one? Yeah, that's what I got.
I made that.
Oh yeah.
Oh,
Yeah, you're right.
I think for it.
Bro,
No, he just looked at me and said number 4.
yours looked different.
No, he just looked at me and said 4. I said it's 4.
Voice off, 3, 2, 1. Jackson, where is this going to be? Give me the quadrant that you predict.
4.
Okay, agree with that? Silent yes, disagree, silent no. I'll put a store here. Any silent no's? I don't see any. We'll check it out. Is it going to be the same orientation, Kylie? Is it going to be the same orientation? Is it straight up and down with J at the top, L to the right, and K to the left? Do you think it's going to have that exact orientation?
No.
Probably going to be flipped. Let's test it out and see. First thing you're going to do is the first transformation they give us. Rotate this guy counterclockwise. When you do that, what happens? For the love of Pearl. There you go. I just rotated it counterclockwise, and there's my new coordinates. What are the coordinates of L prime, Tanner? Let's check it out. If I'm going to the right, I'm actually going 4. So let's go over 4 down 2. There is L prime. Where is J prime at, Elliot? Where's J prime going to be at? Good. Cool. And where is K prime at, Maya? Good. Connect your points. We're not done yet. What's the last transformation they want me to do, Colby? When you're reflecting across X, I'm going to go across the X-axis, and it's going to go up. What's the coordinate or the ordered pair going to look like? Which one is the same, the X or the Y? If I go across here, what part of the ordered pair changes? What part's the same? From L prime up to L double prime, what's going to change about it? Felix. Let's check it out. So the Y is going to change from a opposite sign, negative to a positive. Let's make this one purple. L prime reflects 2 and goes up 2. This turned into 4, 2 from 4, negative 2. When you reflect or do 2 different transformations, it goes from just a prime to a double prime. So instead of one quotation, or one apostrophe, you're going to put two apostrophes. It looks kind of like quotation marks in English. From L prime, was that J? I did not label that right. This should be J down here. From J prime, go up 7, 1, 2, 3, 4, 5, 6, 7, and then go across 7. 1, 2, 3, 4, 5, 6, 7. That's J double prime. That tells you you did two transformations. K is the same thing. Up 3, go across 3. That is K double prime. Take a look at this guy. Could I have gotten from regular JKL to JKL double prime with one single transformation? Turn and talk to your partner. What could I have done from black to purple? 3, 2, 1. Kieran, what would you have done?
Flipped it across the line.
And let's use a math term instead of flipped. It would be reflected
Reflected.
across the y-axis. So in this section, let's put, yeah, you could have. That is why math is so dang beautiful. You can do two things, or you could just do one thing. JKL could have reflected across the y-axis. At the end of today's bronze, you're going to have a chance to be an artiste yourself and go ahead and create your own 2 transformations, maybe even 3 transformations to make it tricky and look different than your partner's. Nice. Okay. Is this figure, JKL double prime, congruent, similar, or neither to JKL? One of these things is not like the other. Remember, similar shapes are going to be changing in size. Congruent is going to change location. What do you think this would be, Andrew? Beautiful. This thing does not change any size. It does not have a different area. JL is the same as JL double prime and JL double prime. These are the same length. Huh?
You said double prime.
Double prime to prime. You get what I mean. Next example. 2 more different transformations. Reflect this figure across the y-axis to create image A, then translate 3 units to the left and 2 units down. Help me reflect this guy across the y, Sarah. Start up at this point. Where do I go?
3, 5.
Here's your y-axis. You're going to go over 3 and up 5. What point changed, Sarah, the x or the y? The x changed because you flipped across the y. Do the same thing with this one. 1, 2, 3, 4, 5, across 5. Okay. We got those 2 points. Do this one over 6, across 6. Over 6, across 6. Over 5, across 5. Over 3, across 3. We have all our points. Connect the dots to make it look like the same shape. This was image A. We've done one of our transformations. Kylie, help me with the second one. What do they want me to do? You can start with any point you want to. Let's start with this one. Go 3 left, 1, 2, 3. Go 2 down. Once you do 1 point, I like to just either put a dot or cross it out or do something to tell me that I've already done that point. Go to the next point, since these aren't labeled. Go 3 left, 1, 2, 3. Go 2 down. Put an X or some dot at that point so you know you've done that one. Go to the next point, 3 left, 2 down. Next one, 3 left, 2 down. 3 left, 2 down, 3 left, 2 down. Connect your dots. That is figure B. And let's answer some questions about Mr. B. And is the figure you created congruent, similar, or neither? Sarah, what do you think? It is congruent again. Why is it congruent this time, Felix? It moved location. It did not change area at all. There was no dilation. How many pairs of parallel lines does figure K have? Kind of going back to the first homework question. Turn and talk to your partner. How many parallel lines does this first figure have? Go. Let's make it pink. How many pairs of parallel lines? 3, 2, 1. How many pairs? What do you think, Jacqueline? Okay, let's check. Where's the parallel line do you see? Did you catch the one that I'm highlighting? Okay, is there another pair of parallel lines somewhere? Colby? Where? You could also do these, so that's one pair in red. You could do another pair in pink. Jacqueline, do you agree with that? So how many pairs total are there? We could say there's 2 in this shape. You couldn't say these 2 corners are because they are going to get back together. There are 2 pairs of parallel. What about A? How many pairs of parallel from here? You could probably eyeball it and get the answer, Colby. What do you think? How many pairs for A? There's going to be the same amount, 2 pairs in A. And how many for B, Maya? There's also 2. This thing does not change shape, so you're going to have 2 pairs all the way across. Question? No? Next page. Big idea, looping back to unit lesson 1 of this unit. 2 figures are congruent if 3 things happen. If you can get the second obtained by the first in a sequence of transformations, boop, translations, back up. That's the most common blunder I make in this unit. It's the first one. I'll take it as a win. Yeah. Translations, in my mind, translations sound like transformations because they have the first like 5 letters the same, but they are different. What's a transformation again? Yeah, Tony? What's a transformation?
Something that changes the location and how the shape is placed.
And it can be any of the 4 we've learned is a transformation. So a translation is a transformation, a rotation, a reflection, a dilation. Those are all transformations. But the only 3 things that make something congruent is a translation, a rotation, and a reflection. Cool. Last example, a triangle JHK undergoes a series of transformations to create ZWO. We're going top right to bottom left. Describe what transformations could have occurred. Be specific. If you're saying reflect, say reflect across Y or X axis. If you're saying translate, say how many X and Y. You're going to create this on your own in the next minute, and then we'll share some of our options. Oit. Trying to talk to your partner. Compare what you said. Sorry, Maya, you're just gonna have to pretend like your paper's in front. Ba-doo, ba-doo, boo, 2, 3, 2, 1. These first two are going to work, and this student said reflect across the Y. From JHK to ZWO, this person is gonna have a slight blunder, but we'll fix it. They reflected across the Y, and then they went up 3. What is the blunder for this translation, specifically going from JHK to ZWO? Sasha? So if they want to go from this shape to there, we're just going to change that to down. It should be translate down 3. You can go from this shape over and then slide it down 3. That would still work. Anyone have the same transformations? Anyone do this? 1, 2, a few of us. Give me another one, silent hands. If you have a different set of transformations, what could you do to go from here to here? Yeah, you're good. Colby, you said you had something different. What was yours? You did the same thing? Okay. Anyone have something different? There is. You could reverse it. You could start translating 3 units down, and then you could reflect across the Y. So you could do it the opposite, but just reverse order. Could you rotate it? I think you'd have to do 3, because you'd have to rotate, then you'd have to reflect, and then you'd have to translate. Cool. You'll have a few more in bronze to play around with. Take out your appointments. Go to